Okay, Joe, we're here at Roseburg, and I noticed something odd about your layout.
And what's that, Rick?
Other than that easy DCC control panel, there aren't any other control panels in the whole layout.
That's one of the nice things about digital command control and walk-around layout design.
But how do you control things?
The main reason you see layouts with a big control panel is the need to independently route power to have individual control of the locomotives. But with DCC, that need's gone.
So how does DCC work then?
And I especially want to make the wiring easy to debug with nothing but a screwdriver.
Well, that sounds good to me. I'm all ears.
So the first thing I do is I run my bus along the front of the layout to make it easy to get to. I use suitcase connectors. 3M calls them insulation displacement connectors, or IDCs, to make connecting the track feeder drops easy. I use 12-gauge stranded wire for my power bus. That's heavy enough I can run the 50-foot length of the layout and not get more than a 5% voltage drop. Yes, Rick, it's the ability of the taillight bulb to keep a short from ever registering at the booster. That's the key. That lets you keep the trains running within a single power district, even if another train in the same power district happens to cause a short.
Now, how do you manage that?
I simply cut gaps in the track so that each power district contains several train length blocks, and then the feeder to each train block has an 1156 bulb attached to it. If a train happens to short the track in that train block, a train that's in another train block but in the same power district keeps right on running.
Oh, because the power booster for that district doesn't see the short.
Right, Rick. Any train that's in another train block keeps right on running, even though it's in the same power district. So it may slow, but it won't stop. If a loco happens to bridge the gap between the programming track rails and the regular layout rails, you can fry decoders or blow the programming circuitry in your command station. The secret to wiring the programming track safely into the rest of the layout is to include a switched dead track section between the programming track and the rest of the layout. Cut gaps in both rails, as shown in the diagram, to create these 3 track sections. If your programming track is stub-ended rather than a through track, as shown here, you can get away with a single dead section only at the end that connects to the rest of the layout. Since each of these 2 locos has a different type of decoder, this will make the speed matching more of a challenge. If you have identical locos with identical decoders, often just copying the settings over is all you need to do. Although the locos are the same here, the decoders are quite different, which is better for this demonstration. We put the 2 locos on the track in Dillard, and we decide that loco SP9235 with the DH142 decoder will be our reference loco, and we will speed match 9157 to it. The recommended resistor values go from 270 ohms to 330 ohms. So which one should we use? Let's do some testing and find out. I connect up 2 bulbs in series, then clip some test leads to the blue and white wires, connecting the white wire lead directly to one of the headlight leads. Using some test leads with alligator clips on the blue wire side, let's first connect the 270 ohm resistor and see what we get. Okay, that's nice and bright. Now let's try the 300 ohm resistor. Yeah, less bright. And finally, the 330 ohm resistor. Yeah, even less bright, but still plenty bright for headlights. The less bright the bulbs, the longer they'll last, so I opt for the 330 ohm resistor. There, now that fits nice and snug. The corners of the speaker face have holes. We want the enclosure to be sealed so we can get the best sound out of the speaker. We'll pass the wires through one of the holes and plug all the holes with a bit of putty. With the cab interior insert removed and the nose lip removed, let's test fit the speaker enclosure into this location. Yep, fits nicely. We'll position the speaker face up so the sound can exit out the open cab window.